This is from page 228. You said number 91 and 93?
Yes.
91 is 4y cubed minus 96y squared. Minus 96y squared. And then plus 576y. And we are supposed to factor that bad boy. Okay, what do you want to do first?
I guess look for common factors or variables.
Exactly. So what jumps out at you? Something jumps out at me. I don't know about you, but I've noticed that there is something in common in each one of those that we could pretty easily pull out.
Well, a y.
The y. That's exactly what's going through my head, right? Like when I look at this, the first thing I look at, it's not even the numbers. I just immediately, the first thing that goes through my head is, okay, what are my variables doing? Okay, we have descending powers, yeah, and we have a y cubed, y squared, a y. Oh, hey, there's at least one y in every single one of these, which means I could pull it out. And so if I pulled out one y, what would I be left with here?
4y squared.
Okay, and then?
Minus 96y.
Yep, and then what?
Plus 576.
Yes. Okay. Now, when I look at this, I think, okay, I have a quadratic, right? I have a variable squared, a variable to the first power, and then no variable. So that's good. Another thing I notice, I'm not 100% sure about this guy's factors. I'm not even sure about that guy's factors. I'm talking about the coefficient now. I'm talking about 576 and 96 and 4. But one thing that I noticed, that the first thing that pops into my head is, remember, like a guiding principle here is we're not trying to find the number all in one fell swoop that we could pull out. Like we could do this one step at a time. And so what I noticed though is that's a 6, that's a 6, that's a 4. Those are all even numbers, which means they're all divisible by 2. So I'm thinking, why don't we try to pull out a 2 first and see what happens? So let's do that. If I pull out a 2, what am I left with? You tell me.
2y squared.
Okay.
Minus 48.
So?
Y.
Yes. And now that one's going to be hard. But check this out. I remember long division.
Oh, geez.
And so 4 goes in.
Wait, aren't you supposed to put a 2 there?
Oh, yeah. Thank you. That'll work. That'll change my answer a little. Okay, so a 2 goes into 5 2 times, leaving me 4. Then we have, we'll just go to 17. 2 goes into 17. 8 times, leaving me a 16. We drop the 1, drop the 6. 2 goes into 16. Looks like 8 times. Okay. So 288, and I'm just going to kind of quickly double check. If I multiply that by 2, I get the 16, carry the 1 and 16, and the 7, and then that'll carry the 1 and the 2 and the 4 and the 5. Yes, okay, good. So plus 288. Okay. Now, what do you notice about each one of those numbers?
You can take out 2.
We can take out another 2, right? That's anytime I'm factoring a number, and I'm not talking about necessarily factoring a polynomial But just anytime I have a number and I'm trying to find its factors or break it up or something, my first question is it even? And if it's even, I know I could pull out a 2. And so like the very first thing that goes through my head with each of these is, hey, that's an even number. I'm gonna pull out a 2. Okay, so I'm gonna pull out a 2. What do I write out front?
4y.
4y, that's how I would do it. Now, what does that leave me?
Y squared minus 24y
24y, huh?
plus 144.
Uh-huh. Okay. Now this looks doable, right? Like I have again, a quadratic, right? Something squared, something to the first power, something to the 0 power. And that looks good. So, okay. So back to our steps that we talked about last time. The first step was pull out any common factors. And I think the common factors are done because now we're down to a 1 and we can't do anything with that. So my next step was to write the parentheses. So I'm going to go ahead and do that. Okay. So now, without using our brains, what has to go in the first place?
Y.
Y, right? It has to be a y and a y to give me y times y gives me y squared. So a y and a y. Okay, we're done with the F. Now let's do the last. So in other words, we're done with the first because we're thinking first, outer, inner, last. We're basically unfoiling this guy right now. Now the last, what might go in? Well, what do we have to do? You tell me.
Find the factors, right?
Right. So in other words, 144 is equal to something times something else. What do you want to do?
Well, there's 1 times 144. There's 2 times 72.
Uh-huh. One thing I noticed though is 2 and 72, that's going to make a pretty big number, right? Like it's either going to be 70 or 74. And I'm looking at that and I'm thinking 24. What else is 144?
3 times 48.
Okay. Still not going to help me out. What I think of for is that it sounds now one thing when we're doing this, one thing that we should have in the back of our mind are perfect squares. Is 144 a perfect square?
Probably.
No. How about that guy?
Okay.
Yeah. So that's one of the first things you want to check is this number here, and I didn't say that, I don't think explicitly, but if we have in our head some squares and some cubes and stuff like that as we're doing this, like that is one of the first things I asked myself was like, okay, what is this thing? And you know, and how we did it last time, right? Like if we had something like I'm trying to think of stuff we had last time, but like if I had 28 or what about how about 12? If I had 12, well, my first guess is going to be 3 times 4. Why? Well, because those numbers are very close to each other, whereas 1 times 12 are not very close to each other. But then again, I mean, it depends on what's in here, right? Like if I see that that's a real big number in there, sorry, like, you know, if I had 12 on the outside, 1 times 12, well, it's either going to be 13 or 11 or, you know, negative 13 or negative 11. And so it depends on what's in the middle there. I usually go for these guys here first because they're closer to each other, whatever. But whenever something's a perfect square, I usually try that first. So like 144, like you said, yeah, it's 2 times 72. That's cool. But I know that 144 is 12 times 12. So that's going to be the very first thing I try. So, and I happen to notice that that middle part That's going to be nice. So, okay, I have a 12 and a 12. And so when I do my outer inner, what do I get?
12y
Mhm.
and 12y.
And 12y. Is there a way we could combine those to give me negative 24y?
I'll make them both negative.
Both negative. If they're both negative, we have minus 12y. Minus 12y does give me minus 24y. And so what do I need? So, okay, we're already sure that this needs to be 12 and 12. So what do I put in here and here for the signs?
2 negatives.
Negative, right? Negative here and a negative there. And if we wanted to be really slick, we can rewrite this and say, well, that's the same as 4y times y minus 12 squared, like that. But I mean, if you leave it like that, that's fine too. But okay, here's this. And now let's just double check it, right? I'm just gonna kind of do it out loud, right? The y times y first gives me y squared. Good. Outer is minus 12, inner is minus 12. So that gives me minus 12 is minus 24y. Good. Negative times a negative is a positive. 12 times 12 is 144. Good to go. Throw a 2 into there and I do get that. Yeah. Throw the other 2 into there and I do get that. Y goes back into there to give me my original thing, and I am done. Check. Sound good?
Mm-hmm.
Okay, cool. So what was the other question?
93.
93. Okay, so check out 93. So 93 is a cubed x cubed, a cubed x cubed minus b cubed y cubed. Is there any common factors?
No.
No common factors. So I noticed that it's something cubed, right?
Mm-hmm.
And if you remember before, I gave you this hint a while ago with one of your problems. I said, anytime you have something like this, and I don't want to use A and B because we have A and B up there. How about Z and W? Z cubed, W cubed is the same thing as the quantity ZW.
Oh, right.
Right? And so that's the trick with this one. That is the first thing I'm going to do here because when I'm looking at this, this is what goes through my head. Okay, no common factors. Okay, now what? Cubes minus cubes. Oh, difference of cubes, but that's not quite what I've seen before, right? I would need to change this into something I've actually seen before. And so my first step would be, well, if I could turn this into a true difference of 2 cubes, and so that's what I'm going to do. I'm going to say, okay, then ax cubed minus by cubed. And honestly, as I write this, what would be going through my head is something like this. Well, wait a second. What does that mean? Well, it means to take ax times ax times ax. That's what the quantity ax cubed means. Then my brain I'm double checking and I'm thinking, well, wait a minute, is that the same thing as yeah, because I could rearrange multiplication to go in any order I want. So I could write it as 3a's times 3x's. Yeah. A times A is that right there. That's just a fancy way of writing that. X times X is that. That's just a fancy way of writing that. And then I'm just kind of making sure I'm keeping myself honest. Because again, it's not like I have this as a rule in my head, or like whatever. It's more like, well, I know that I could do something like this. And then when I go to write it down, I try to justify it in my brain because of course it's like, wait, do you add the exponents? Do you multiply the exponents? How do the exponents work? Well, I just try to remember that means that change into that, and so on and so forth. On the conversely, right, if I see this, I say, well, that means that. Can I rearrange it? Yep, I could rearrange it like that. Oh, there's 3 of those guys. Yep, so that means that thing cubed, and so on and so forth. And do we need to finish this one up, or are you good from here? Or would you like to? We could do it.
Could we finish it?
Yeah, let's finish it up. Okay, difference of cubes. So I think, wait a minute. There's one of the 5 formulas that Justin's ever going to tell me to memorize is the sums and differences of cubes. And so, okay, that's a difference of cubes. So what I'm going to do is write this because I know the shape of it, right? The shape is like this. We have the thing to the first power, the other thing to the first power, the thing to the second power, the thing times the thing, and then the last thing to the second power. So I'm giving myself some room for that. So now I'm thinking, okay, the first thing here to the first power, the second thing to the first power, something like this. The first thing squared, the first thing times the second thing, so a little bit more room. And then finally, the last thing squared. Right, that's what goes through my brain. It's like, I remember the shape of the thing. Then I'm going to fill in the blanks here and say, yeah, it's the first thing to the first power. So we have AX. Then the second thing to the first power is just BY. The first thing squared is AX, quantity squared. First thing, second thing, we have AX, BY. And then the last thing goes in here, squared. Okay. Now I remember that nifty little acronym. What was the acronym?
So,
and so I'll put O here, O here, and the always positive. So what sign do I put between those guys?
a negative.
A negative, because it's the same as what the original was. Then what sign here?
Positive.
Then what sign?
Positive.
Always positive. Okay, so now technically we're done, but I'm going to clean this up a little bit because parentheses in parentheses is ugly. So I'm going to say, okay, that's just AX minus BY. Now, I mean, that's also good, although since it was written like that to begin with, and well, there are a few reasons why we might want to do this. I don't want to ramble more than I already do about this, but I'm going to go ahead and rewrite this. What is this? How can I rewrite this thing?
A squared, X squared.
There you go, right? And again, right, what does that mean? AX times AX, group the A's together, group the X's together, and that's what you have. Now, what we usually do here is these X's and Y's are usually seen as variables. A's and B's are usually seen as coefficients. So we put the A's and the B's together. So what would I have here for this part?
A, B, X, Y.
A, B, X, Y. We'll usually do it in that order. In alphabetical order. So then finally, what do we have in the end?
Plus B squared, Y squared.
There we go. And I notice this does not factor anymore. There's not a 2 anywhere. And so I think we are done. That should be the end of that guy right there.
Okay.
And there's nothing else to factor out, right? I mean, and if we've done our factoring correctly at the beginning, then we shouldn't end up with any common factors here. But
Right.
I don't trust myself when I do this kind of stuff. Like, it's like, because I could easily miss a common factor. And then at the end go, oh, wait a minute, there's a 2 here and a 2 here, and then pull it out at the end. So that's always kind of like my final check. I just kind of go through and say, yep, nope, 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 okay, we're good. And so, all right, good to go?
Yes.
Oh, okay, so for today, for this weekend, chapter 5, part 6, it says factoring, a general strategy. I would like it if, so part of your homework tonight is going to be reading over this.
Okay.
We're not going to talk about it today because it's really just the same stuff we've done for the past 2 days. They just kind of blend it all together. Whereas like before, you know, you had little sections like factor by using this method, factor this way, and then like this, it's all kind of blended together, which is nice because that's how you're going to encounter it in the wild, right? So, and then they give you some general strategies. And, you know, I normally hate everything about textbooks. This is actually pretty good. I like this. So what I'm going to suggest is that you read over 5, 6, and they have 7 examples. What I would recommend that you do, 1 second, my phone is going off. And it has made me freeze. Okay, cool. So what I'm going to suggest that you do is look at example 1. Do not read example 1. Man, go away. I don't want you calling. Okay, sorry. Look at example 1. Cover up the answer, right? And just attempt problem 1 on your own. If you get stuck or whatever, then look at how they do it and follow along. Ditto with part 2 and 3 and all the way through 7. Just attempt them before you look at the answer, and that will help enormously. Go through those, and then I will give you your homework assignment. I'll write it all up on the board when we're done. You're going to have 11 questions from part 5, 6. It's all pretty straightforward. It's pretty much everything that we've done thus far. It's not, there's nothing new there. So there's that. So moving on to the topic of today, it's 5, 7, solving equations by factoring. And this is really why we're doing this in the first place, this more or less. So, okay, one way to solve an equation is by factoring. Okay, so if we have something like this, actually, okay, you'll do this one first. So x squared minus 6x plus 8. And we want to know what values of x make that equation true, right? We do this so often in math, right? This is very much like what we were doing with systems of equations, right? We have an equation. We want to know what values can I plug in there so that that becomes a true equation. Well, we could just factor it out. You factor this. How do I factor?
Hold on.
Okay.
X. Yeah, parentheses.
Okay, you need parentheses, right? So what went through my head first was no common factors, moving on to writing my parentheses. And check out how I'm doing that. I'm going to write this like this every single time, right? Trust me, this is good habit to get into. You have an equation and you go to modify it, right? Copy down the entire equation. Okay, so what goes in the first bit?
X.
X is, right, that's the only way, because x times x gives me x squared. Okay, now what are my possibilities for out here?
2 and 4.
I like 2 and 4 because I hear 2 and 4 and I think 6, right? And so, yeah, okay. So what will my outer and my inner multiplications give me?
X, 4x and 2x.
4x and 2x. And how do I combine those to give me a minus 6x?
-4 -2.
Okay, so it looks like we should be good to go. So I'm going to go ahead and write in my 2 and my 4. Now we just need to figure out signs. What sign goes in front of the 2?
Minus.
And what about the 4?
Minus.
Good. All right. Now, so this is the cool thing about this is anytime you have two numbers, any two numbers in the world, multiply them together. If you get out a 0, there are 3 possibilities. Either A is equal to 0 and B is not. B is equal to 0 and A is not. Or they're both equal to 0, right? So we're going to use this principle. It's a fact about the real numbers. This is how real numbers work. So this means, so anytime we see something like this, this means that A is equal to 0 or B is equal to 0, right? And so, okay, then that means that either this is equal to 0. So it must be the case that either x minus 2 is equal to 0 or x minus 4 is equal to 0. So what does x have to be for this equation to be true?
2.
It has to be 2. And if it's a bit more complicated than that, right? Like, and I could just kind of see it like, oh, if I plug in a 2, I'll get a 0 right there. But sometimes this term right here is a lot more complicated. And so it's nice to put it like this. And then you don't use your brain and you say, oh, okay, I'll just plus 2 to both sides. And I end up with x equals 2. Okay. Ditto over here. What makes this equation true?
4.
X equals a positive 4. Okay. And so let's check. Let's see if this works, right? Now, I'm just going to take what we have here and plug it back in. So if x is equal to 2, then we have something squared minus 6 times something plus 8. I plug in a 2 for x, and so I get 2 squared and a 2. And 2 squared is 4. What's 6 times 2?
12.
Okay. And plus an 8. And what does this work out to? What's 4 minus 12?
-8.
I think so. Plus 8 equals 0. Okay, so that checks out. That one checks out. Nice. What about if we had plugged in a 4? Let's see if that works. Okay, so plug in a 4. Plug in a 4. Now what do I get? What's 4 squared?
16. Right?
What?
No, 4 times 4. 16.
16. Now what's 6 times 4?
24.
4. Plus 8. Let's check this way. What's 16 plus 8?
24.
24, right? Okay, so 16 plus 8 is 24. Minus 24 does equal 0. Okay, so let's just sum up what we've done. We're given an equation that, good luck trying to solve that. Like, anytime I'm given an equation and I'm told solve for x, I always think the first thing my brain goes to is get x on one side of the equation and get everybody else on the other side of the equation. Good luck trying to do that when you have a squared and when you have x squared and x not squared in the same equation. Like, you could try that. You'd have like x squared minus 6x equals -8. You could try to factor out an x. Now you have x minus 6 equals -8. You're not in any better shape there, right? Like, trying to get the x all by itself and getting everybody else on the other side is not going to help us in this situation. And so, yikes, what do? Well, when you have, remember I called this a quadratic equation. That's what it is. This is a quadratic polynomial. When you have one of those, then the next thing you want to do is say, well, can I factor this guy? If I can factor him, then this becomes a really easy thing to do because of that nifty little fact that you take two numbers and multiply them together. Either that one's 0 or that one's 0, or they're both 0, but in this case, that can't happen. But so we're going to use that nifty little fact to get us to allow us to solve for x. And you'll notice that with a quadratic equation, right, when you have an x squared, you end up with two answers, right? And that kind of makes sense because let's look at this. Let's say we had, can I erase all this? Can I erase this?
Yes.
Okay, so this kind of makes sense because if I had something like this, x squared equals 4, what this says, now in this case, I can get the x all by itself, right? And I could say, well, hold up, you're telling me that you took a number and multiplied it by itself and you got out a 4. Well, that number must be what?
2.
What number? What? I couldn't hear you.
I'm sorry, my birds are screeching.
I know.
2.
2, right? And it's like, yeah, it has to, x has to be 2 because 2 times 2, right? 2 squared is equal to 4. But does that only work for positive 2? I guess what I'm asking is, does negative 2 also work?
Yes.
Yeah. And so we actually get two possibilities, right? That negative 2 also works. So we have to say, well, x is either equal to 2 or x is equal to negative 2. Does solve this equation. Just check, believe it or not, just do it, right? Plug in the 2. You get 2 times 2 is 4. Equation's true, ready to roll. Plug in negative 2. Negative 2 times negative 2 is a positive. 2 times 2 is 4. Yeah, so negative 2 also works. But let's check this out. Now this is kind of cool because we could say, well, hold up, let's see if this is all consistent. Whenever we have a quadratic equation, we usually like to get it equal to 0 so that we could try to factor it, like using that method that I was just talking about. So if I subtracted 4 from both sides, we could rewrite this like this. Yeah. And now, can we factor that guy?
No.
Why not?
Wait. Yes. Sorry.
Yeah, we can. If it was plus, then we couldn't factor, right? If it was x squared plus 4 equals 0, we would be in bad shape. Although you can factor it, but we're not going to get into that. That's a topic for something else. This we could totally factor. This is a difference of squares, right? So you factor this. What do I have?
Parentheses and then get your x
Got my x.
and negative 2.
So we're thinking 2's and 2's, right? Something like that. Now what about my signs?
Negative 2 and positive 2.
Negative and positive. Yep. Has to be. Let's see why that's the case, right? First gives me x squared. My last gives me negative 4, which it has to be. My outside and my inside, I can see they have to cancel out, right? They have to go to 0, so they have to be opposite signs, right? negative, so the outer will give me negative 2x. My inner will give me a plus 2x, which work out to 0. Another thing we could do is say, well, hold up, this is like this right here. That is a difference of 2 squares. That's one of the few things that Justin said you need to have in your brain, that when you see, oh, something squared minus something squared, that is that, and then we flip signs right there. Has to be that way. And, you know, again, we could multiply that out to verify that, but that needs to be something that's in your head. And so when you see something squared minus something else, just a number by itself, first question in your head is that something squared? And yeah, in this case it is. That's just 2 squared. So we have x squared minus 2 squared. That's a difference of squares. And so we could say, yeah, that's going to be an x and a 2, an x and a 2, and then we have to have opposing signs right there. So, okay, how do we link this back into what we're talking about for today? Well, and we already did this, right? We already said just from the very beginning, that was an easy one to see, that that's either x equals 2 or x equals negative 2. But had we gone about it this way and said, well, hold up, get him on that side, and now do this type of thing, and now either that's equal to 0. So in other words, either x plus 2 is equal to 0, or x minus 2 is equal to 0. And so solving this guy gives me what?
Negative 2.
X equals negative 2. Or if I solve this guy, I get
2.
X equals 2. Now, what I do, and we could see finally linking this all back together, that yeah, this is all consistent, right? Whether or not you happen to have something easy where when solving for x, you could get all the x's on one side. And what you could do in this case is say, well, what I could do is to undo that squared, I'd take a square root of both sides. But you have to know that whenever you take a square root, whatever that means, is that you do get 2 answers. And so you get plus or minus 2, right? But that's exactly what we're saying, right? It's nice to see that this is consistent. We could either, if you get the x by itself, you could take this route right there. Or you could say, well, get it equal to 0, then I could factor it. And then these factors are going to tell me what the x's have to be. And usually what I do when I get to this point, I just ask myself, okay, I know the game, right? How do I make this number 0? Everything that's in there. And so then I just ask myself, well, what do I have to plug in for x to make that a 0? And I can see, well, if it's a negative 2, negative 2 plus 2 will be 0. And so I would just write that down. Here, it's nice because it's a minus. And I could say, well, what number do I plug in for x to make that equal to 0? Well, it has to be positive 2. Give me just a second. Peter wants a hug. Oh, yeah, big hug. Big hug. Oh, thank you. Thank you. Okay. Does that make sense?
Yeah.
Okie dokie. Oh, you're all right, buddy. Hey, you're okay. Oh, you're doing okay. Trust me, you're just fine. Someone's frustrated. He's all right. He's good. He took it. He went straight down. No, you're all right, buddy. No, I think he needs another hug. I'm sorry. Come here. Come here. Big hug. Big hug. Big hug. Mwah. Hey, be careful. There's some stuff you could trip on. Okay. So now this is going to get interesting here. Your homework is going to involve a lot of this. In fact, like half this whole section is simply they give you equations and they say solve the equation, right? Solve for x. And so what we're going to do is we are going to get everything on one side, get it equal to 0, and then factor it down.
Okay.
So here's another example. 12y squared minus 3y. How do they write it? Yeah, equals 9. And we're not solving for x. In this case, we're solving for y. And now, immediately, I'm so ingrained to think, oh, I'm solving for y. I need to get all the y's on one side. And so all the y's are on one side. Uh-oh. Oh, man, how do I go about doing that? And then something clicks in my brain and says, oh, that's right. This is a quadratic. It's written funky, right? But I could turn this into a quadratic. Then I should be able to factor it down. And then I'll be able to use that nifty little fact that two numbers multiplied together equals 0 gives me a, that I could solve it. So anyway, so what do you want to do first with this guy?
Subtract 9.
Right, so I'm going to get the 9 over on one side so that I can have this guy as a quadratic equation equal to 0. Now, what do you want to do?
You can factor out a 3.
Yes, we can factor out a 3. So I'm going to write my 3 right here, give myself some space, write a 0. And now what do I write here in the first place?
4y squared
Good.
minus y
Y
minus 3.
minus 3. Okay, now we have some options, right? Okay. First off, can we factor it any further?
No.
Well, I mean, can we pull out? Are there any other common factors? Is what I meant, and you knew what I meant.
No.
So, what's my next step?
Write your parentheses.
Okay, so I'm going to do that. I'm going to write parentheses like this. I'm not going to forget that 3. Although what's interesting is at this point, we could divide both sides by 3. And it wouldn't change anything. We'll talk about that in just a second. But interesting to note. But note. So what do I write in the first place?
2y.
Say again?
Would it be 2y?
We could try 2y. 2y and 2y. Now we could try 4y and a y. That's the thing about this. When you have this guy going on, when you have a coefficient in front of your y or your squared variable, then you have options. My first guess is to try 2y and 2y. I like that. Yes. Okay. Now, what about this guy?
3 and 1.
That's the only way to do it, right? A 1 and a 3. So I'm going to do that. A 1 and a 3. Okay, so when I do my outer multiplication, what do I get?
6y.
6y. And then the inner multiplication gives me
2y.
2y. Is there any way to combine those to get 1y?
No.
No, I'm not seeing it. And then I think, well, maybe I wrote this in the wrong order. And so if I flip it and do a 3 and a 1, oh, but it's still a 2 and a 2. That's not going to change anything. I'm still going to end up with a 6y and a 2y. So 2 and 2 don't work. So what do I have to try?
1 and 4.
So I usually do the bigger number first, and that doesn't matter how you write it. Okay, so now we know there's only one way of getting a 3, but which one do you want to try first? Where should I put the 3 in the first place?
Just I guess the second.
Okay, so we'll put the 3 in the second one. Let's see what happens. Okay, so we know that the first is going to give us 4y squared. We know that the last is going to give us a 3. And so what does my outer give me?
12y.
And what about my inner?
1y.
And is there any way to combine those to get a negative?
No.
No. So what do we got to do?
Yeah.
Flip them. So I'm going to put my 3 here and my 1 here. Now, when I do my outer, I get what?
4y.
4y. And when I do my inner, I get what?
3y.
3y. How do I combine those to give me a negative 1y?
Minus 4 plus 3.
Minus 4 plus 3. Okay, so we're sure that the 3 goes here. I'm going to go ahead and write it in. We're sure that the 1 goes here. Now all that remains is figuring out who gets the negative. What goes where?
I guess the 1 gets the negative.
The 1 gets the negative. Yes. And as I do that, I double check and say, well, wait a second, hold on. I need the negative 4 there, and so I will get a negative here. And then if I put a positive here, I will get a positive 3y. So yes, that should work. Just real quick, I'm going to double check. 4y times y gives me 4y squared. Outside gives me a negative 4y. Yes. Inside gives me a positive 3y. Put those together, I get a negative 1y. Good. Positive 3 times negative 1 gives me a negative 3. Good. Putting that back, that works. Okay. Looks good. So now what do we do? In order to solve for y. So remember, this has something to do with something equaling 0. So when we had, in this case, so remember that when we had something like this, we said that what this really means is that there's 2 possibilities. Either this thing is equal to 0, or this thing is equal to 0. And so then we ended up with 2 equations. How do we get 2 equations out of this guy?
Do you divide by 3 first?
We could. And yes, we could. Go ahead and do that. We divide everybody through by 3. That kills that guy. 0 divided by 3 is what?
0.
So 0. And this is what I was saying earlier, is that 4y plus 3y minus 1. So what I was saying earlier is that any constant you have out there isn't going to change any of this. That could have been a 700, and we'd still end up with these guys right here. It's kind of cool. And so, okay, now what do we do?
We solve each of the parentheses equal to 0 or something.
Exactly. We're saying each one of these has to be equal to 0. So what equation do I get from the first one?
Real. Stop.
Hold on. Okay. So you have 4y plus 3 equals 0.
4y plus 3 equals 0. And what's my other equation?
Y minus 1 equals 0.
Y minus 1 equals 0. So let's do the easy one first. This means that y has to equal what?
1.
Y equals 1. That's one of them. Now, another way I could have done that, and this is just something to note, is that once I got to this point right here, what my brain does is I kind of think, is there a number that I could easily just plug in right there to make that thing 0? Because, for instance, if I plugged in and I could look at it and see, oh yeah, if I plug in a 1, I'll have 1 minus 1. That will be 0. that'll be something. That'll be something else, but I'll have a 0 and I'll have a 0 times something else. Who cares what all that other stuff is? This number will be 0. Everything there is going to go to 0 and it will give me a true equation. And so that's kind of what I was saying earlier, that we would eventually talk about, that we could divide both sides by 3 to get it into this form right here. Or we could just use the fact that, well, at this point, if I make this number 0, and it doesn't matter how many of these things we have, we could have 27 y plus 1, y minus 3, 4y plus 7, dot, 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 1,000 of them, and then equals to 0. Any one of them that makes it 0 will make it a true equation. Does that make sense what I'm saying? And so yeah, we could go ahead, divide both sides by 3 and then get this, or we could just say, okay, at this point, now that we have something factored, it's all multiplication over here. So I know then, just by that same principle that we were talking about earlier, if any one of them are 0, then we could go, okay, so what about this guy? How do I solve for y there?
You subtract 3 from both sides.
Subtract 3. That is what I would do. Leaving me 4y equals -3. And now what do I do?
Divide by 4.
Divide both sides by 4. That gives me y equals -3/4. Okay. And now what I like to do at this point is I'm just going to take each one of my equations, and we will do this just because this is the first time you've seen something like this, and I think it's instructive to go back and plug this into the original equation. But right now I could just see, like, from this right here, this equation right here, forget about these 3's. If I took y equals 1 and plugged it in, I could see that 1 minus 1 would be 0. I would have something here. I guess it would be 4 plus 3 equals 7, whatever. 3 times 7 is 21. We'd have 21 times 0 does equal 0. And so that would work. Another thing I could see is that if I plugged in a -3/4 into here, and what my brain does is it just kind of imagines this. It says, okay, there's a 4. There's a -3/4, and it's a +3. So as I'm doing this and I get this as an answer, my brain just says, well, what would that look like if that y were replaced with this? And then my brain says, well, it would look like that. And then I think, well, a 4 kills a 4 right there. And then we would just have -3 plus 3. -3 plus 3 is in fact 0. And so that entire thing right there would turn into a 0 if I plugged that number in right there. And that's another way you could kind of, and like when you do 1,000 of these, then you'll be able to just see it. The same way when I look at that, I don't need to set this up and then add 1 to both sides. I can just see, if I plug in a 1, I'll get out a 0 right here. Here I could say, well, I'd need to divide by a 4, yeah, and then I would need to have an opposite of whatever this is, which I guess would be a -3, so a -3/4. But that'll come with time, right? Right now, we could just say, well, every single time I have something like this, I could just say, I'll take however many factors I have and just set each one of them equal to 0. And so, finally, let's just take our answers that we got, y equals 1 and y equals -3/4, and we'll plug it into the original equation and see if it works. So I'm going to give myself some room here. Am I good to erase stuff?
Yes.
Okay. So back to the very first equation. If I plug in a y equals 1, I get 12 times 1 squared minus 3 times a 1. Should equal 9. I'm not sure, but I'm going to check. So I'm going to put a little question mark right there. Now I have 12 times 1 squared is 1. Or yeah, 1 squared is 1 times 12 is still 12. Minus 3, is that equal to 9? 12
Yes.
minus 3 is 9, and it is indeed equal to 9. Check. Okay, so that solution does work. Now let's try this second. It's going to be a little bit more ugly, but let's see what happens. So we have 12 times the thing squared minus 3 times the thing. Is that equal to 9? So the y is going to be minus 3/4. We have a minus 3/4. Okay, so what is minus 3/4 squared? First off, what's a negative times a negative?
A positive.
Positive. So I know that in the end, that should be a positive number. And so in other words, I have 3/4 times 3/4. So what is that?
Hmm, 9/16.
Yes. 9/16 minus. Let's go ahead and take care of this. A minus minus. Can I pull that negative out? I think I can, right? Just make that, instead of saying minus a minus number, we'll just say it's plus a positive. And so then what do I have? 3 times 3/4. Well, that's the same thing as 3/1 times 3/4. So in the same kind of thing that I did here, we just multiply numerator, multiply denominator. We have numerator over denominator. What do I have right here when I'm done?
3 times 3/4 times 1, which is 9/4.
Good. 9/4. And I'm asking, is that thing equal to 9? Okay. So, real quick, let's just see. I'm going to go ahead and just do this. I'm going to say 12 is 3 times 4. I'm going to rewrite it like that. Times 9/16, but 16 is 4 times 4. So I could see that we could cancel out. Looks like 1/4 from here. That and that are gone. So we have 3 times 9/4. You following me what I'm doing there?
Yes.
Okay. So yeah, all I did, and enough, yeah, I just canceled out a common factor. 12 is 3 times 4. 16 is 4 times 4. And so really what I've done here is I've kind of thought about this as all like that. 12/1, just put them all together. The 4's cancel. I'm left with 3 times 9. What's 3 times 9?
27.
27. I was about to say no, it's 36, but you're right, it's 27. So 27/4. Okay, so 27/4 plus 9/4. Hey, that's a common denominator. I could do that right there. So what's 27 plus 9?
36.
And what is 36 divided by 4?
9.
9. And so it looks like, yes, that is equal to 9. Check. Both of our solutions work. And so that's how we solve an equation. That's how, given a quadratic equation. So it used to be, and it's still in my head, that whenever I hear solve for some variable, in this case, solve for y, my brain immediately goes to get all the y's on one side, get everything else on the other side, and just plug at it. Good luck. good luck if you're trying to do that here, because you can't get the y all by itself. So we have to see, so then like we have to start adding to our toolbox now. When they say solve for a variable, we go, okay, can't, like the first question is, can I get all the, in this case, y's on one side? And with a quadratic, we can't, not necessarily. And so in this case, no, there's no way to get the y only purely by itself. So now we have a new tool in our toolbox, which says, well, if you can get this equation, if you could rewrite it so that this equation is equal to 0, which you can, 12y squared minus 3y minus 9 equals 0, then you could take advantage of the fact that if you can factor it, if it's factorable, then you end up with this nifty little fact that once you factor it, which is, that's what we had, 4x plus 3, y, 3, y minus 1. If you could rewrite this like that, then we could say, if this will be true for every single number that's true, for every single factor that equals 0. So, okay, I want to say one more thing before I give you your homework. Any questions with this stuff?
I'm good.
Okay, so there's just one more thing. I think, yes, in your homework, you are only given quadratics. They're all quadratics. So
Okay.
it'll be stuff like this.
No.
And
Stop.
you're gonna put it in, you're gonna make it equal to 0, factor it out, and then do this type of thing. Now, however, there's just something to note, like that this works no matter what type of polynomial you have. So let's say you had some kind of crazy polynomial with, I don't know, like x to the 5th power plus, I don't know, 3x to the 4th plus x minus 5 equals 0 or something like that. If you had something crazy like that and you were able to factor it, in this case, you would have 5 factors. And whatever they come out to be, let's say it's something crazy like a half and 2x minus 3 and x plus 5 and x minus 2, and how about x plus pi, right? Like you're able to take something and factor it out, or even if that you never even knew what that was and you were just given this to start off with, and we were to solve for x, what we could say is, well, the same principle applies. If I plug a number into there and that number is 0, what number can I plug in for x to turn that number into 0?
Minus 1/2.
Minus 1/2. So this tells me that if x is equal to minus 1/2, then that entire thing, I don't even need to think about what these are. Even if there's another x plus 1/2 over here, it'll also be 0, but who cares? This could be a trillion billion. You take that, whatever it happens to be, multiplied by 0, well, that's going to be 0. Right here, what do I plug in for x to turn that guy into 0?
Minus 5.
If x is equal to minus 5, then that factor will be 0. Then the entire thing goes to 0. This will be a true equation. What about here? X equals what makes that 0?
2.
If x is equal to 2. What about this guy right here?
Negative pi.
X equals negative pi. What about that guy?
3 over 2.
3 over 2. Good. Excellent. If I have 3 halves. Now, yes, this kind of the way I just approached that is kind of like the way that the book says, find the greatest common factor. It makes you think that you have to have it all in your head. Well, if this were uglier than it is, you could just say, well, hold up. we don't need to try to get it all in my head at once. I could just say, what did you just ask me? Well, 2x minus 3, we are wondering when is this guy equal to 0? From there, we add a 3 to both sides. That would give me a 2x equals positive 3. Divide both sides by 2. And so we don't need to get overwhelmed. Like, you did a great job. You figured it out, right? And you could see what I mean, like with simple factors like this, you could just kind of visualize, well, I would need to kill the 2. So 2 is going to be in the denominator. And then the opposite of whatever number that is, minus 3, well, it'd have to be a positive 3. So boom, there you go. And then you could see, like, yeah, plug it in. But they will be way uglier, in which case you just say, well, hold up, I don't need to do that. And I could just do this and solve, and then I'll have this. And we could see that, yes, every single one of these, if I plug in a -5, I'll have something that's not 0 here. It won't be 0 here. -5, -2 is -7. -5 plus pi is some stupid number. But when I do plug in a -5 here, I will get a 0. And so then everything will go to 0. Ditto, even if I have a 70 to the 100 to the 1000
Where are you?
front, doesn't matter. Does not change what the actual, we call them the zeros of a polynomial are, or the roots of a polynomial. That's what this is all about. So, any questions?
Say that again. I'm sorry.
I was just saying, so once you've taken a, once you have a polynomial equal to 0, then, well, yeah, we'll get into that next time. So all I'm saying is once you factor down a polynomial, then these, well, yeah, I was saying that the key here is just like when we had our equation from before, we ended up with this plus, and that was a minus. But really, it didn't matter what number that was. The interesting part is that I just need to turn that right there, that factor, into 0. And we found that, yes, if you plug in a -3/4, that will make that 0. If you plug in a 1 there for y, that'll make that 0. And it doesn't matter if this was a 3 or a 23 or a 723. Doesn't matter what number's out there. It doesn't matter if I even had more factors. If I had made this a y plus a 7, that it will still be true, because we've written it in this form. It's still true that when I plug in a -3/4 in here, then this entire side goes to 0. Plug in a 1 into here, that entire side goes to 0. And so they are still solutions to this guy. That's what I was saying.
Right.
And we later on, very soon, we're going to call these roots or zeros. These solutions, they are called roots or zeros of a polynomial.
Yeah.
Okay, so any questions?
No questions.
All right, cool. So we are going to do some homework. So this should be homework 9 or something, 8 or 9.
I think it's 9.
I think it is 9. So, okay. 6. Homework 9, chapter 5, section 6, on page 231. One through 45, every other odd. And make sure that you do number 45. Like I might have counted wrong. I think if you're doing every other odd, 45 will be included in there. If not, make sure you do number 45. It's a challenge problem. Yeah, have fun with that.
Great.
Yeah, it's not bad. You just, I mean, and by the time you've done all of those, you should be in the groove of it, and you'll be like, okay, I think I know what to do first here. Shouldn't be too bad, but it is challenging. So, then it is all right there. Yes. So then, chapter 5. Section 7 on page 233. So this works out to 11 problems. The next one will also work out to 11 problems because it's the same thing. It's number 1 through 45, every other odd.